Hey there, curious minds! Welcome back to another exciting journey into the world of science. Today, I'm diving into a groundbreaking experiment that changed the way we understand genetic transformation in bacteria. This experiment, conducted by Fred Griffith in 1928, was a pivotal moment in the field of genetics. Grab your virtual lab coats as we explore Fred Griffith's fascinating 1928 discovery in 3D. This experiment not only opened new doors in microbiology, but also set the stage for future discoveries in genetic research. Alright, picture this. It's 1928, and Fred Griffith, a British bacteriologist, is investigating a deadly bacterium called Streptococcus pneumonia. This bacterium was a major cause of pneumonia, a serious and often fatal disease at the time. This bad boy is responsible for pneumonia, a disease that was claiming many lives. Griffith was determined to find a way to combat this deadly pathogen. Griffith's mission? To find a way to fight it. He believed that understanding the bacteria's behavior could lead to better treatments and possibly a cure. He starts by working with two strains of the bacteria, the smooth strain, which is virulent and deadly because it has a protective capsule, and the rough strain, which is harmless. The smooth strain's capsule made it difficult for the host's immune system to attack it. Imagine the smooth strain as a villain with armor, and the rough strain as a harmless civilian. The smooth strain's armor was its capsule, which protected it from the host's immune defenses. Griffith's experiment begins with injecting mice with the smooth strain. Sadly, the mice die. No surprises there. The virulent smooth strain was too much for the mice's immune systems to handle. Next, he injects mice with the rough strain. This strain, lacking the protective capsule, was easily defeated by the mice's immune systems. The mice live happily ever after. The rough strain posed no threat to their health. But here's where it gets interesting. Griffith wasn't done yet. He wanted to see what would happen if he combined different elements of the bacteria. Griffith then heats the smooth strain to kill the bacteria and injects the dead smooth bacteria into the mice. The mice lived. This showed that dead bacteria, even if they were virulent when alive, posed no threat. So, dead bad guys, no harm, right? Now the twist. Griffith's next step was to mix the dead smooth strain with the live rough strain. Griffith mixes the heat-killed smooth strain with the live rough strain and injects this mix into the mice. Guess what happens? The mice die. This unexpected result puzzled Griffith. But when he examines the dead mice, he finds live smooth bacteria. How's that possible? The harmless rough strain had somehow transformed into the deadly smooth strain. Griffith concluded that some transforming principle from the dead smooth bacteria transformed the harmless rough bacteria into deadly smooth bacteria. This was a monumental discovery. Think of it as the rough strain getting a makeover from the dead smooth strain. This discovery was revolutionary. It suggested that bacteria could exchange genetic information in a way that was previously unknown. It suggested that bacteria could exchange genetic information, a process we now know as transformation. This was a groundbreaking concept that would pave the way for future genetic research. This was the first step in understanding genetic recombination in prokaryotes. Griffith's work showed that genetic material could be transferred between organisms, leading to new traits. Years later, scientists like Avery, McCarty, and MacLeod identified DNA as the transforming principle. They built on Griffith's findings to show that DNA was the molecule responsible for heredity. Griffith's experiment laid the foundation for modern genetics and our understanding of DNA as the genetic material. His work was a crucial step in the journey to uncover the secrets of life at the molecular level. So there you have it. Fred Griffith's 1928 experiment in 3D, a simple yet profound discovery that changed biology forever. His work continues to inspire scientists to this day. Fred Griffith's 1928 experiment in 3D, a simple yet profound discovery that changed biology forever. His work continues to inspire scientists to this day. I hope you enjoyed this journey through time and science. Understanding these foundational experiments helps us appreciate the complexity and beauty of life. Don't forget to like, subscribe, and hit the bell icon for more amazing scientific explorations. Your support helps us bring more fascinating stories from the world of science. Until next time, stay curious, keep exploring, keep questioning, and keep discovering the wonders of science.